name is Kira Van Winkle, and I'm a middle school science teacher in Iowa. If you're watching this video, it means that your class has started a new unit, but you missed all or part of the first lesson. Before I begin walking you through this lesson, I'd like for you to gather a few supplies. You will need your science notebook, several pieces of blank paper if you don't have your notebook available, and you'll also need a writing utensil. We're going to have some opportunities to walk through some of the activities and discussions that took place in your class while you were gone, and you will need those materials. You are welcome to pause the video while you gather those materials and then press play when you're ready to move on. Your teacher began the unit by telling an interesting story about their iced coffee, and I wonder if you have experienced anything like this. I often stop on my way to school to pick up an iced coffee from my local coffee shop, but I don't always get to drink it right away, and it ends up warming up enough that the ice melts and it waters down my coffee. I mentioned this to the barista, and they suggested that I try one of the cups they have for sale in the shop that's supposed to keep my drink colder longer. The barista swears that these cups they have for sale work way better and that they're better for the environment because they're reusable. So I decided to try it. I've included an image on this slide to show the two different cups. Take a minute and observe the two cups, then consider the questions on this slide. On the left-hand side, you'll see the fancy cup, which is the one that the barista suggested. And on the right-hand side, you'll see the regular cup, the one that ends up getting watered down. Why do you think the drink in the regular cup warms up? And then how could the fancy cup keep the drink from warming up? I'll give you a minute to think about that. So I talked about this with my own class, and the cups to them seemed really similar in appearance. And so we're a little bit skeptical about how effective the fancy cup could be compared to the regular cup. So we decided that testing the cups was the best way to see if the barista's claim that the fancy cup would keep my drink cold longer was correct. Please find a new page in your science notebook and jot down some ideas about how we could go about testing the two cups. So at the top of your page, write the claim written in the green bar at the top of this slide. You'll write, claim, the fancy cup works better than the regular cup. Then think about these questions as you jot down your ideas. How could we test this claim? And what evidence could we collect to prove or disprove this claim? Go ahead and pause the video here and record your ideas in your notebook. And when you're ready to move on, just press play. So you've got your list of ideas, and here's a list of what my students thought we could do to test out these cups. Do you see anything on this slide that may be in common with what you wrote down? We decided that we would probably want to test the temperature change over time. And we weren't really sure how long we should be testing. So some of us thought 10 minutes, some of us thought 30. A few people even suggested maybe like hourly or over the course of an entire day. We also want to see how long it takes the ice to melt in each cup, since that seems to be what's watering down my coffee. And then we also want to see how long it takes for the temperature to increase. So if we can collect some data from these ideas, maybe it'll be worth buying the fancy cup if the evidence from our tests shows that it's better. Before we test the two cups, though, we need to think about how to make a fair test. We spent a few minutes in my class talking about what we think could make the test unfair and what we would need to do to ensure that it was a fair comparison between the two cups. On this slide is some of the ideas that the students came up with. They suggested that we start with the same temperature of water in each cup, and that the same amount of water is in both cups. They also think the same amount of ice in each cup would be helpful, and both cups, like the ones in the first slide, need to have lids. We also thought it needed to be in the same location so that the room temperature was the same, and even on the same surface. We were concerned that maybe a wood surface versus a laminate surface may make some sort of difference. And then we also suggested that we not touch the cups during the test. We were afraid that our body heat could mess up some of our results. We also thought same type of liquids should be in each cup. So maybe water, maybe coffee like I was drinking, maybe pop or soda. we weren't sure. Okay, so what I would like you to do before we go over the results from my class's test is copy this data table from this slide into your notebook beneath your stop and jot ideas from earlier. In my class, we decided that we wanted to collect data every 10 minutes for 30 minutes. So you'll notice on our data table that we start at minute 1 because we wanted to make sure that they were at the same temperature, and then every 10 minutes after for 30 minutes. Your class may have decided something different, so make sure that you chat with your teacher or your classmates when you get back to class, and also collect the data that your class took as you were absent. I'm going to share information that was gathered in my own classroom, though, so that we can move through this part of the lesson. Pause the video here to copy the data table into your notebook, and then press play when you're ready to continue. Okay, so here's how we conducted our investigation of the 2 cups. And again, your class is probably pretty similar, but maybe it did something a little bit different, so you're going to want to check in. Because we wanted the test to be fair, we made sure to use water from the same pitcher and use the same amount of water in each cup. It was 400 milliliters in each cup, and we also made sure that the water was ice cold. We wanted to be sure that the cups were as similar as they could be, so we placed our thermometers in the cups through the holes in the lids, and then we made sure that those lids were securely on top of the cups. Then we waited 1 minute and recorded the temperature of the water in each cup at the same time, and that ended up going in our data table under minute 1. Then we collected data every 10 minutes after, so at 10 minutes, at 20 minutes, and at 30 minutes. So this slide shows sample data from my classroom. So let's look over the data. It shows that the regular cup warmed up more over time than the fancy cup did. And overall, there was a 5.8 degree change in temperature in the regular cup, but the fancy cup only changed 4 degrees over 30 minutes. Make sure you ask your teacher and your classmates for the data from their investigation and record it into the data table you copied from the previous slide. We had some time to kill between 1 minute and 30 minutes. So while we waited for our temperature change data, our class created like a similar, different what we wonder chart and discussed our observations and ideas. So here's what my class discussed. We thought similarities between these 2 cups were that they were both made of plastic and they were both clear or transparent or see-through. We had different language to describe that. And then we also said both cups had a lid and a straw. We thought they looked like they had about the same amount of water or ice, and we also know that they're both getting warmer in the same environment. Some differences, though, is that the regular cup, although it's made of plastic, is a thin, kind of flexible plastic, and the fancy cup was a thicker plastic. The regular cup only had 1 layer of plastic, but the fancy cup looked like it had maybe 2 layers. Maybe there was even something in the middle between them. We also said that the lids were different. First of all, that they were kind of different thicknesses, just like the cups. So the regular cup had a thinner plastic lid and the fancy cup had a thicker plastic lid, and they both attached to the cup differently. So the regular cup snapped on, and then the fancy cup was like twist on or screw on. And then we also noticed as we did this investigation that the regular cup got warmer faster. And we also noticed at the end that the regular cup had like water droplets on the outside of the cup, but the fancy cup didn't. That made us wonder, though, what does thicker plastic do to keep the water cold? And is it a special kind of plastic? And how come 2 layers seem to be more effective? So we're wondering, like, what's in between those layers? Is the lid keeping the cold in? Is it blocking the air outside and not letting it into the cup? And what would happen if there was no lid? What if there wasn't a straw? And what if where is the water coming from that's outside the cup, the regular cup? And what would happen if we had conducted this investigation if the room was dark? So when scientists are trying to understand a phenomenon, they think of it and study it in terms of systems. They identify the important parts of the system and how those parts work together. This can give them clues about what to pay attention to and to test. So let's think of our cups as a system. We're going to call the regular cup, just the regular cup system, and the other, the fancy cup system. So in your notebook, make a new heading like what's on the slide here that says important parts of the system. Take a few minutes and jot down your ideas using these questions to guide you. And they may have similar or different parts. So it may be helpful to identify which kind of cup you're talking about. So what are the parts of the cup systems? And then what do each part do in that cup system? So we mentioned in the other one, there's a lid. What's the job of the lid? And then how do parts work together to keep a drink cold? So pause the video here and jot down your ideas. Again, we're identifying the important parts of the system, what they do in the cup system, and how they work. Press play when you're ready to continue. Okay, so take a look at this class's ideas. Are any of these ideas similar to what you wrote in your notebook? When we're identifying important parts of the system, we should ask ourselves what would happen if that part wasn't even there. Would it change the outcome? If so, then it's probably important. And we decided that there are a lot of important parts in these two systems. So for instance, both cups had sides or walls on them. They had lids, even though they were different in the way that they attached to the cup. They both had straws. They both had a similar material, but it was like thinner and thicker. We also noticed that there's liquid inside the cup and that we would see something different if there wasn't liquid inside the cup. We also said there was a solid ice inside the cup. And we also noticed that above the water line, there was some air between the water line and the lid of the cup. We also thought that the room temperature could be an important part of the system. There's air outside the cup, and we're thinking that if it were a warmer room versus a colder room, that could change our results. We also thought that maybe light had something to do with it. Those cups are see-through, so we think maybe the light can get in somehow. So now that we've identified the important parts of the system, I want you to sketch out a model of the systems in your notebook. Your model should explain or try to explain why the drink in the regular cup warms up over time and if or how the fancy cup could slow the warming process. So as a reminder, our model should try to explain what's happening that leads the drink inside to warm up or not warm up as fast. And we need to make sure we're using symbols, color, and words to help communicate these ideas. So if you could grab your notebook, make a new section, and then put at the top of a new sheet of paper the heading Cup System Models. And then, as you can see on this slide, we're going to divide it into regular cup system and fancy cup system. So reminder, we're explaining what happens that leads the drink inside to warm up or not warm up as fast, and we're using symbols, colors, and words. I'll have you pause the video here while you add your models to your notebook, and when you're ready to continue, just press play. Okay, now that you've finished your model, what do you think you can conclude about the cup systems and our temperature data? It seems like the fancy cup did work better, but we're not sure why. So we have a good start on these two systems and what they're about and some ideas about how each part works. We're going to plan to share our ideas on day 2 of this lesson. And before you come back for day 2, I'd like you to do some quick investigating at home. So what are some other systems in your home that are designed to maintain the temperature of something inside it, either hot or cold? A refrigerator or freezer would be an example that uses electricity to keep things cold. However, our cups are not using electricity. So let's try to look for other systems that do not use electricity to maintain the temperature of something. And maintain means keep the same. Okay, so I would like for you, before you come back for day 2, to jot your ideas in your notebook below your model of the cup systems, as shown in this slide. So you're just going to put a line underneath that says home learning. Again, you're coming up with other examples of things that would keep something either hot or cold and make it not change temperature much, and it needs to not use electricity. We're going to begin day 2 by reviewing our investigation data and then sharing our home learning. So if you only missed day 1 of this lesson, you can stop the video here. Be sure to share your ideas for investigating the cups, the important parts of the system, your systems model, and your home learning with your teacher when you return to class. If you only missed day 1 of this first lesson, you can conclude the video here. If you missed the second day of the lesson in class, you can continue watching. Let's begin day 2 of our first lesson. You're going to need the same materials as were needed on day 1, which were your science notebook or several pieces of blank paper, along with a writing utensil like a pencil or pen. It's also going to be helpful to have your home learning from day 1, as well as your systems model. So during day 1 of this lesson, we tested 2 different cups to see which cup would be better at keeping a drink cold. This is the data from my classroom that we used in day 1 of this video lesson. Take a look at this data. If you were in class at your school for day 1, you may have your own data in your notebook to use for this part of our lesson. Okay, so we've reviewed the data from day 1. As you observe the data, I would like for you, please, to record a conclusion or 2 in your notebook beneath your data table. You should have the data table in your notebook. If you need a minute to go back and look at the data, you're welcome to pause and kind of rewind the video. I would like for you to add a couple conclusions. What are some things that you have figured out from our data from the cold cup test? Pause the video here, press play again when you're ready. All right, so here's some conclusions that we shared in another class. I'm wondering if any of your conclusions seem similar to these. So we said that the water in the fancy cup was colder at the end of 30 minutes than the water in the regular cup. And we noticed that there was a 1.8 degree difference between the regular cup and the fancy cup. When we touched the cups, the outside of the regular cup felt wet, but the fancy cup felt dry. We also noticed that the outside of the regular cup felt cold, so cold and wet, but the fancy cup was still sort of like normal temperature, kind of felt the same as when we started the investigation. There was still ice left in both cups, but we think there was maybe a little bit less than when we started in both cups. And we also said that the air around the regular cup kind of felt like it might have been a little bit colder, but it wasn't as cold around the fancy cup. Okay, so now that we've discussed our conclusions and evidence from our cup investigation, the next step is to develop a model. Okay, so you had a discussion in class about the models that you drew at the end of day 1. The goal of this discussion was to figure out areas of agreement and disagreement and come to a consensus on what the class is thinking about when it comes to explaining why the fancy cup works better than the regular cup. So the next slide contains a picture of a model that was developed in another class. I'm going to have you take a look at that model and at the models you created in day 1 of the regular and the fancy cup. So you're going to compare your models with the model on the next page. I would like for you to identify a couple of areas of your model that seem like your ideas were similar. You can either write down some notes in your notebook, or you can just make like a check mark on those parts within your model. So if they are similar, you're going to put a check mark. And also identify areas where there might be some differences. So either you're not sure that you agree, or maybe that's a new idea to consider. You're going to put a an asterisk or a star next to those things. So let me review. You're going to put a check mark on the parts of your model that seem similar to the model that I'm going to show you on the next slide. And you're going to put an asterisk or a star next to the things that are different. Okay? Okay, so now take a minute, identify areas of similarity and difference between this model and the model in your notebook. I'm going to have you pause the video here while you record your thoughts and observations, and then press play when you're ready to resume the video. As a reminder, be sure to check with your teachers and classmates when you return to class so that you can see the model that was developed during your class's consensus discussion. It may be different than what I showed you on the previous slide. Your class also shared out the home learning assignment from day 1, where you identified examples of other systems that are used to keep things hot or cold. So take a look at your home learning. Are there other experiences or ideas that you have about systems that are used to keep things hot or cold? If you have anything to add to your home learning notes, now would be a good time to do that. And you're welcome to pause the video here if you need some more time to do that. Press play when you're ready to continue. So here's a list of ideas that are similar to our cup systems that were taken from another class. So take a look at your home learning notes and see if there's anything on this list that's similar to what you wrote. So some of the things that this class came up with were like a coffee tumbler, and that's meant to keep coffee warm. And we're thinking that it works because it's metal. We also talked about the Stanley cups, and we said that they could keep things both hot and cold. We think because they're metal and maybe because they're thicker material, and maybe even because there's a plastic on the lid, even that little there's like a little plastic cover that kind of twists over the lid, over the cup, the straw hole on the lid. Maybe that has something to do with keeping things warm and cold as well. We also talked about igloo or like Yeti coolers, and they're meant to keep things cold. But then we also had some students who said that like their dads or moms like to grill, and sometimes they keep their food in a cooler to keep it warm for a longer time. And they think that this works because it's a thick, heavy plastic with a heavy lid that latches. We also talked about lunch bags. There's some like silver material inside of those. They have zippers and fabric, and they even feel kind of squishy, like maybe there's some foam in there. We talked about winter coats are meant to keep you warm, and that's because they have thick layers, zippers, sometimes they're even waterproof, and they block out the cold but keep in the heat from your body. We also talked about how maybe they had some pockets as well. We talked about cold packs. So that could be like the ones you maybe put in your freezer at night, or maybe it's like the kind that you have to pop to get them to turn cold. And we're thinking that there's like a gel or ice inside, but there's a plastic outside. We also talked about blankets, how they keep you warm when you're cold because they have a thick fabric and it keeps in your body heat but blocks out the cold air. And then we also mentioned like a pizza carrier. When you have pizza delivered, there's a container that has usually their fabric with some Velcro. And then we think maybe there's also like silver, kind of like the lunch bags in that container as well. So do any of these ideas make you think of other experience or ideas? If so, add them to your list. Okay. And then also, again, be sure to check in with your class when you return and see if there's any ideas from your home learning that could be added to your class list. So part of our goal as scientists is to apply our learning to other phenomena around us. So our goal in this unit is to use what we learn about the cup systems to explain other similar phenomena, like the igloo coolers or the pizza delivery bag. So for your exit ticket today, take one of your related phenomena from your list or from the list on the slide before this, and make a model that explains how you think this item works to keep that substance inside it warm or cold. So follow the steps listed on this slide. You're going to diagram the important parts of the system. So what's inside, what's outside, and any important structural features. Step 2, you're going to use the model to answer these questions. How does the thing inside warm up or cool down? And then how do the parts of the system work together to keep this from happening? And again, since we're developing a model, we're going to use colors, symbols, and words to help explain our ideas. We don't need to completely explain how these phenomena work, but we do want to identify the things that could be happening that may explain how it works. So maybe we have some questions. Feel free to add question marks if you're not sure. I'd like for you to create this model on a new page called the Related Systems Model. And I'm going to have you pause the video in just a moment so that you can work on that. This is the end of day 2 of our first lesson, so be sure to finish your related systems model before you continue on to day 3. If you only missed this part of lesson 1, you can stop the video here. Be sure to share your notes and home learning when you return to class, and if you missed the 3rd day of the lesson in class, finish your model, and then you can continue watching this video lesson. If you need to pause while you finish that assignment, please do so now. Okay, we can now begin day 3 of the first lesson. If you have it available, please get out your model diagram of the cup systems from day 1, as well as a couple pieces of paper or new pages in your notebook. You may also want to have your model of your related phenomena from the end of day 2's lesson. You're also going to need a pen or a pencil to write with as we move through this part of the lesson. So at the end of day 2, you were assigned a task in which you were to create a model that explains how a related phenomenon works. And we do this so that we can make connections with the world around us and hopefully explain multiple phenomena as we learn more about that original one. And while you were gone, your class spent some time sharing their models in a gallery walk. So be sure when you get back to take a look at your peers' work so that you can have a good idea of what their ideas are. So at this point in the unit, we have a lot of notices and wonders about how these systems work to keep things cool or warm. So let's use those to help us generate questions about how or why the fancy cup and related systems work to maintain the temperature of the stuff inside them. So make a new section in your notebook titled Driving Questions, as shown on this slide, and be sure to number your questions as you write them. The questions that you develop should be questions that we can answer through investigation and questions that could help us explain how these things work the way that they do. When you get back to your classroom, you're most likely going to be asked to share your questions with your teacher and add questions to your class's driving questions board. Make sure that you use things like your regular cup and fancy cup model, your model for the related phenomena, maybe even the data that we collected in my class on the data tables. And then pause the video here and take a few minutes and brainstorm some questions about the cup system or patterns you observe in our data about those systems. When you're ready to continue, you can just press play. So here's an example from another classroom of driving questions that were shared by students in Mrs. Howart's science class. So some of the questions include things like, what makes a bigger temperature change? Turning on the heat in your house or turning on the cold air in your house? They wondered, does condensation play a part in making water or another liquid warmer or colder? They wonder what's inside of heat packs and ice packs. How do coolers work? How do the materials of a container affect the temperature of water? How do fans cool down the air? Why does dark stuff, get hot faster? How are things like cups or lunch bags able to keep things both hot and cold? Why does it take so long to make something cold? Where does the air of a container leave, or does it even leave the container? Do different drinks change temperature differently when you're using the same cup? What are some common chemicals that interact with cold or hot? Why does heat pass through plastic so easily? And how do thermometers work? How do they calculate temperature? Do any of these questions look similar to any of the questions from your list? Do they make you think of any other questions that you'd like to add to your list? If so, go ahead and do that. Now that you have your questions recorded and have seen an example of another class's driving questions board, start a new section in your notebook titled Ideas for Investigations, as shown in this slide. Take a minute to jot down ideas of these things that we could do in class to investigate our cup systems or our related phenomena more closely in order to answer the questions from your driving questions board. Here's some ideas for investigation from another class. I'm wondering if any of these ideas look similar to the things that you jotted down. So this class suggested that we test metal cups to see if they get the same results. They also suggested testing without lids and comparing data from that first cold cup test. They thought that maybe we should measure the mass of the cups before and after to see if anything is escaping from the system. They also think that we should change the temperature of the air around the cups to see if the changes inside the cups are similar. And they suggested looking at materials under a microscope to figure out how they work. They thought that we should try testing in a dark space instead of with the lights on. They thought we should try testing with other cup materials, so metal cups, glass cups, styrofoam cups, etc. They thought we should try different colors of cups, not clear. So they're thinking maybe darker cups or brighter colors. They're also wondering about putting hot water in the plastic cups instead of cold and seeing if the temperature changes are similar. They suggested trying other liquids, so not just water, but maybe also milk or lemonade or coffee or pop or soda. They thought changing the ice cubes, so like having less or more. Some students even suggested using the bullet-shaped ice cubes or the nugget ice cubes, or nugget ice, I guess. They also suggested that we dissect or take apart a 2-layer cup and try to figure out what's between the 2 layers. Are there any ideas on this slide that you'd like to add onto your list, or maybe that make you think of other ideas for investigation? If so, go ahead and add those to your list now. We've now concluded lesson 1 of your new unit. Be sure to check in with your teacher and share your notes and models with your teacher and your classmates when you return to class. I hope you have a great time investigating these systems and applying your learning to the other similar phenomena.